What's up, guys? In this video, we're going to work on how to solve a quadratic equation by completing the square with no fractions. And we're going to do that through 5 hand-selected problems that I've designed exactly for you. Cheers. In these 3 examples, let's kind of go through the completing the square. Now, again, really, guys, the process of completing the square, what we're trying to achieve is put something in vertex form. Vertex form had that binomial squared. Would you guys agree? And once we know the binomial squared, transformations, all that kind of stuff was relatively easily. Now, I kind of recognize something here. And typically, when we were dealing with quadratics, we always looked at like factoring, right? And hopefully, since I gave you guys those 73 problems, your brain is a little bit trained to automatically look at a trinomial and say, is this factorable, right? So immediately, I look at this, and is this factorable? Yeah, it's factorable to what? Hey, guess what? That's in vertex form. So literally, just by factoring it, I achieved what I wanted to achieve. It's in vertex form. Now, for the sake of completing the square, let's actually do that to get to this method. But hopefully, you guys will see that just by factoring this one really quickly, I achieved exactly what I needed to achieve. That's why knowing how to factor is so very helpful. But let's go ahead and do the process. So the process that I said I'd put back up there, is we're going to put parentheses around our first 2 terms. So what we're trying to achieve here is we already had a perfect square trinomial. We got lucky. That's really not going to happen. But I did that because that's actually what we're trying to achieve every single time when we complete the square. We're trying to create something that we can factor to a binomial squared. This example, I just gave it to you from the beginning. So how do we create a perfect square trinomial every time? What do we do? Second step is to take the middle term, b, divide it by 2, and square it. 2 divided by 2 squared is 1. Was that already the term? We already know 1 was in there, right? Then we take that term, and we add it inside of the parentheses. Because by adding it inside the parentheses, you are now creating a perfect square trinomial, which we already knew was the answer, right? But again, guys, if if I say 5 is equal to 5, you'd say, OK, correct. And then if I say 5 is equal to 5 plus 1, you'd say, no, that's not correct anymore. But if I say 5 is equal to 5 plus 1 minus 1, you'd say, that's now correct again. Agreed? So if you add a 1, you also have to subtract the 1. Now, the only reason why I'm going through this problem, because you're really not going to see many of this, is when you create this parentheses, you just created a perfect square trinomial every single time. So it's always going to be factorable. And we already knew it was factorable to x plus 1 squared. 1 minus 1 is 0. And that's why you got the exact same answer. So I just went through this whole explanation of completing the square when we already knew the answer by factoring, right? But typically, guys, you're not going to have a problem that's going to be that simple, right? But you should recognize it. Yes?
Why did you do 2 over 2 squared?
Because that is the process of completing the square, is always taking the middle term, dividing it by 2, and then squaring it. OK? So let's look at the next example. This looks like it's factorable, but is it? No. So what I need to do is I need to create a perfect square trinomial. So what I'm going to do is group the first 2 terms. OK, now my middle term is -2. So I'm going to have y. Oops, I'm sorry. So now my middle term is -2 divided by 2, and square it. So -2 divided by 2 is -1. -1 squared is 1. So I'm adding the same number in this case, and that's fine. But let me get this out of the way. Y is equal to x squared minus 2x. I'm going to add it and subtract it. Now again, did I just create a perfect square trinomial that's factorable? Yeah. It's not the same as this one. It's what? X minus 1 squared, right? Because x minus 1 times x minus 1. The sad part of this, the reason why most students have trouble is they can't factor. That really is the hard part for most students. They just have trouble factoring. But again, guys, it's always going to give you a binomial squared. So you got to think what product multiplied by itself is going to give you that, which would be x minus 1. And then just be careful, -1 minus 1 is -2. Is that a lot easier now to find the vertex, and all that kind of stuff? Yeah, right? So when it's in standard form, converting it to vertex form. Because otherwise, that's not factorable, right? It's not factorable. So that's not fun to be able to figure out the zeros and all that kind of stuff. Now, what about this? This is written as a linear factorization. It's a product of its zeros. Isn't this really easy to find the zeros? Zeros are -2 and -4. But it's not very easy to find the vertex, is it? So what I'm going to do here is I'm going to multiply this. X squared plus 6x plus 8. And then I say, crap, I got to figure out what that middle term is. So now in this case, I know this is not a perfect square trinomial. But what do? Take the middle term b, divide it by 2, and square it. So we're going to take 6, divide it by 2, and square it. 6 divided by 2 is 3. 3 squared is 9. Oh, I'm sorry. Group the first two terms. Right? That's what we want to create a perfect square trinomial on, is the first two terms. So I have y is equal to x squared plus 6x. What do we do with that 9? Add it inside the parentheses. But if you're going to add it inside the parentheses, you have to subtract it outside. Otherwise, you're not going to produce an equivalence equation. Make sure you remember that step. Now, what is this? Is it factorable? I gave it to you on that worksheet. I know I did. So as long as you did that worksheet, then you should be able to factor that. And now, is that pretty easy to find the vertex and all the other kind of transformations? Yeah, that's not easy to find the transformations. That's easy to find the zeros, but not the transformations, right? So that's why a lot of times, that's why the vertex form or creating that binomial squared is going to be helpful for us. OK? Welcome. So what we're going to do is show you how to solve this by completing the square. So the first thing, just like when we were factoring square root method, first thing we're going to do is we're going to set our output value equal to 0. Now to solve this, remember we're going to use the inverse operations for completing the square. So what we need to do is we need to rewrite this into our vertex form. So therefore, we can use the inverse operations. Because right now, we have an x squared and an x. We can't combine them, nor can we isolate them because there's two of them. So what we're going to do is we're going to rewrite this into our vertex form. And so to do that, what we need to do, remember, is our steps. The first step is to make sure that our a is 1. Since our a is 1, we're good. Then what we're going to do is take b divided by 2 and square it. So in this case, we have -4 divided by 2 squared. Well, -2 divided by 2 equals -2 squared, which equals 4. Then what we're going to do is we're going to add that 4 inside or to our first two quadratic terms and then outside. So we're going to add it inside of parentheses and then outside. So what I'm going to do is say 0 equals x squared minus 4x, and then add 4, and then subtract 4. All right? So notice if I remove these parentheses, I would have the exact same equation, right? But the reason why I'm keeping those parentheses, because what I'm going to do is I'm going to rewrite this as now a binomial squared. And that's the whole part of completing the square. What you're doing is you're creating a perfect square trinomial, which you can now factor down to a binomial squared. So this can now be factored down to x minus 2 squared. And then this equals minus 1. Now I can apply my square root. Now I can solve by using the square root method, which means I'm just going to isolate my variable and use inverse operations. So what I'll do is I'll add 1 over here. So I have 1 equals x minus 2 squared. Then I take the square root. And now remember, when taking the square root, I'm going to have plus or minus 1 equals x minus 2. Then I add 2 to both sides. So therefore, I have x equals plus or minus 1 plus 2. So we're going to solve this in two different ways. We're going to have, say, positive 1 plus 2. So therefore, x equals 3. And we can say negative 1 plus 2, and x equals positive 1. So therefore, those are your two solutions by solving using completing the square. Thanks. Welcome. So in this case, what we're going to do is we're going to look at solving this by completing the square. And when completing the square, make sure we're solving. We want to set this equal to 0. And there's a couple important points when completing the square that we want to make sure we're aware of. First of all, we need to make sure that our a in our equation is going to be equal to a positive 1. Then what we're going to do is we're going to want to put parentheses around our quadratic and our linear term, because what we're going to do is we're going to create a perfect square trinomial. And remember, a perfect square trinomial is in the form of x squared plus 2 times the square root of cx plus c. Now, usually, we say, well, what happened to ax squared plus bx plus c? Well, that stuff is all created as well. And you could still even say we have an a. You could have an a, but what we're doing is mainly looking at when our a is going to be equal to 1. So we're going to want a is equal to 1. We need c to be a square number so we can take the square root of it. And if we can multiply by 2, and that's your b, then we have a perfect square trinomial. So I need to create a perfect square trinomial. Now notice, if this is a perfect square trinomial, this number has been multiplied by 2 and then taken the square root. So what I'm going to do to create my perfect square trinomial is I'm going to do the exact opposite operations. I'm now going to take my b, divide it by 2, and then square it. Pretty much undoing all of this to find the value of c that's going to complete the square. So to do that, I take negative b divided by 2 and square it. Well, negative 6 divided by 2 is a negative 3 squared, which equals a positive 9. Now I'm going to take that value and I'm going to add it inside my parentheses to now create my perfect square trinomial. 0 equals x squared minus 6x plus 9 plus 18. So what you can see now is now I have a perfect square trinomial where my c is a square number, and then my b is 2 times the square root of c. And it has to be negative, but that's OK. It can be positive or negative. Now, the important thing is, since I added a 9 to create this, I need to make sure I add a 9 on the other side. Whatever you do on one side of the equation, you have to make sure you do on the other side of the equation to keep equivalent equations. However, you could add and subtract on the same side, and we do that often, and I'll show some examples when I do that. But I think it's probably the easiest to understand. Whenever you do on one side, you have to do on the other. So now I have 9 equals. Now, the important thing, why do we have a perfect square trinomial? Why do we even deal with that perfect square trinomial? Well, we do that is because a perfect square trinomial is very, very easily factored. So now what we can simply do is say, all right, my perfect square trinomial is simply going to be x plus or minus the square root of c. It's either going to be both positive or both negative, depending on your middle term. In this case, my middle term is positive, so it's going to be x plus c. In this case, my middle term is negative, so it's going to be x minus the square root of c, which is 3. All right, so that is my binomial or my trinomial factored into a binomial squared, which now is in this form, which is good because now what I can do is apply my inverse operations. So therefore, I'll have a negative 9 equals x minus 3 squared. Now I can apply my inverse operation. So I'll take the square root, take the square root. So therefore, remember, whenever you take the square root, you have to introduce a positive and a negative. And then also the square root, when we're taking the square root of a negative number, we can rewrite that as a square root of 9 times the negative 1. Well, the square root of negative 1 we write as I. And the square root of 9 is going to be plus or minus 3. So therefore, I have plus or minus 3i equals x minus 3. Add 3 to the other side. And therefore, my final answer is x equals 3 plus or minus 3i. I don't know, my eyes are a little crazy, but hopefully you guys get the answer and understand. Thanks so much. That's how you solve using completing the square. Thanks. These are some things I'm going to be asking of you in a little bit on your test. So the first thing we want to make sure is this says completing the square. Now we need to kind of remember, some of you I know kind of forgot as far as why are we completing the square, what exactly is the process of completing the square. So I'll try to make this as streamlined as possible for you. Now if we're looking into solving this equation, the first thing you would obviously want to do is make sure that our equation is set equal to 0. So if we have variables on both sides or anything else, solve so your variable is on the same side, and you set your equation equal to 0. Or if you have a y or an fx, just replace the y or fx with 0. OK. Now, what we previously did in our last homework quiz is we talked about factoring this. So therefore, this would be 13, and this would be positive 8. Now, exactly what we're trying to think about factoring. What two numbers multiply to give you 13, add to give you 8? And is there any possible numbers that multiply to give you 13 but add to give you 8?
No.
No. So, ladies and gentlemen, this is not factorable. Right? So that's why we're using completing the square. It's important for you guys to understand it's not you cannot factor it. So we have to come up with another method, which is completing the square. And what completing the square does is it provides us with an equation that we can factor. So how do we get that equation we can factor? Well, the first thing is we're going to isolate our first two terms, our x squared and our 8x. Now, when we're completing the square, we got to make sure that our a is equal to 1, which in this case it is. Now we move on to creating something we can factor. So to do that, we do the b divided by 2 squared. If you guys remember that, b divided by 2 squared. So we go to our equation. We say, what was our b? 8 divided by 2 squared. 8 divided by 2 is 4. 4 squared is 16. So 16 is going to be the number that what we call completes the square. It's going to produce our perfect square trinomial. So now what we do is we're going to add the 16 inside this parenthesis, but whatever we add on the right side, we have to add on the left side. So I'm going to add a 16 on the left side equals x squared plus 8x plus 16 plus 13. So now what I want you guys to see, do you guys see now, since I added this 16, I now have a trinomial inside this parenthesis that can be factored. Can it be factored? Well, let me show you. 16 and 8. What two numbers multiply to give 16 add to give 8? It's 4 and 4, right? So I could say 16 equals x plus 4 times x plus 4 plus 13. But really, guys, we don't write x plus 4 times x plus 4. We can just write 16 equals x plus 4 squared. OK? Now, why is it important to write? Why is it important to do this? Because if you guys remember, what we did in the first part of this chapter is we used the square root method. Correct, Ashley? We used the square root method. And you can only use the square root method when you have 1x. Well, guess what, guys? By completing the square, I now only have 1x. So I can solve using the square root method. So now all I need to use is subtract 13 on both sides. So I have 3 equals x plus 4 squared. Now I undo the square root. So I have plus or minus the square root of 3 equals x plus 4. Now to solve for x, I subtract 4 on both sides. And my final answer is x equals a negative 4 plus or minus the square root of 3. So what I have here is y equals x squared minus 10x plus 24. And whoa, I'm kind of getting a little shaky here. So remember what we're going to do by solving to complete the square. The first thing we're going to want to do is set our output value equal to 0, because we're going to want to find the values of x that are going to make this equation true. And what we want to do is we want to go from standard form over to our vertex form. So to do that, we need to create a binomial squared. And to create a binomial squared, we have to create a perfect square trinomial. And to create a perfect square trinomial, we need to find the value of c that is going to complete the square. And what I mean by that is if I just isolate my first two terms, my quadratic and my linear term, I want to make this a perfect square trinomial. And to do that, I got to make sure that my a is equal to 1. So since my a is equal to 1, that's a good start. Now the next thing is I need to find the value c inside. So I need to create a number. I'm going to add a number inside of this that's going to make a perfect square trinomial. And if you remember, a perfect square trinomial looks like this. X squared plus the square root of 2 times the square root of cx plus c, where c was a square number. I remember our square numbers were 1, 4, 9, 16, 25, 36, on and on. So I need to create a number. 24 is not a square number, so I'm going to create a square number that's going to be a part of this. Now remember, these are related times 2 times the square root of c. So what I'm going to do is I'm going to take this number, and what I'm going to do is I'm just going to undo all this stuff. I'm going to, instead of being multiplied by 2, I'm now going to be divided by 2. So instead of multiplying, I'm going to divide it, and then instead of the square root, I'm going to square it. And that's going to create my perfect square trinomial. So in this case, I have negative 10 divided by 2 squared. Well, negative 10 divided by 2 is going to be a negative 5 squared equals positive 25. All right? So now what I'm going to do is I'm going to add that 25 inside my parentheses. But since I'm adding it on the right side of the equation, I need to either add it on the left side of the equation, or I can simply just add and subtract it on the same side. And that's not going to affect my solution. So 0 equals, parentheses, x squared minus 10x plus 25 minus 25 plus 24. And just real quick, a lot of students have trouble with it. If I say x equals 1, and then I say plus 2 minus 2, I didn't change that answer at all just by adding 2 and subtract 2. Since I did it on the same side, my solution is still the true. X still equals that 1 because those plus 2 minus 2 still goes to 0. All right, so now I created my perfect square trinomial. Now what I need to do is factor this down. And we practice a lot of factoring perfect square trinomials. And remember, a perfect square trinomial is you need to make sure your c is a squared number. And you can use the diamond method if you want. Or the x method, 25, negative 10. What two numbers multiply to give you 25, add to give you negative 10? And what we get is we get x minus 5 times x minus 5. And then negative 25 plus 24 is going to equal a negative 1. Now, the main important thing is, though, we don't have an equation that's written like this. We can rewrite this as squared. Just like if I said x times x, that equals x squared. Well, x minus 5 times x minus 5 equals x minus 5 squared. Now it's in this format. And when it's in this format, I can apply the square root method, which means I'm just going to use my inverse operations. So to solve for x. So the inverse operation of subtracting is going to be adding 1. Now, a lot of students get mixed up here because they want to add the 5 over there as well. But remember that 5 is inside parentheses. So by using my reverse order of operations, I need to undo the squaring first. Now remember, whenever you introduce the square root, we got to make sure we do plus or minus. The square root of 1 is just going to be 1 equals x minus 5. And then I add 5. So my answer is x equals 5 plus or minus 1. Well, 5 plus 1 equals 6, and 5 minus 1 equals 4. So therefore, my two solutions are x is going to equal 6 and 4. Thanks.